the energy transfer, and then when the electron one share to another share, electrons are moving, so energy can be transferred. So so between two electrons, there are two kinds of forces. One with the attractive force, another with the repulsive force. So electric force means the electrons are attracting each other. Repulsive force will be the electron also can be repulsing each other. So the electron, due to the attractive force and repulsive force, it can also produce a energy level. So that energy level equation we can write down the equation. So the energy of two particles in the field of each other. So two particles are producing the energy levels. So they are attracting or the repulsing. So that by this way they produce the energy. So this energy is a WR, can be calculated. So this is the minus alpha divided by R plus beta divided by R squared. So that will be the attractive. Here with the repulsion. So R means that this is the radius of the electron, and WR means that the energy level is depending on the electron radius, and also alpha and the beta are the constant. So the combination of the attraction and the repulsion energy, they can this is the attraction force, this is the repulsion force. So by combination, the combination will be the potential energy. So potential energy in the electron is created due to the attraction and the repulsion of those particles. So those particles are attracting each other and repulsing each other. By this way, the potential energy can be produced. So that we can also calculate the force between the atoms A and B. So this will get the energy transfer from the atom to the electron. So this is the atom here. This is the nucleus, this is the electron. So electrons usually are moving around the nucleus. So in this case, this electrons absorb the energy from the atom. This becomes the energy transfer from atom to electron. So energy transfer from the atom to electron. Energy transfer from the atom to electron can be calculated. So that will be the force between the A and B atom. Force can also be the E squared divided by the 4 by E0 R squared. So this is the E is the electron charge, and this is the E0 is a constant, and the R is this is for the radius of the electron. So that's the way we can calculate the force. So this force is causing the energy. So this becomes the force multiply the distance, then we can call the energy. Energy equal to force multiply distance more. Distance more means the electron normally orbiting circulating the nucleus. When you move this electron to the onward or inward, in this case, the energy will be absorbed. So the energy can be absorbed to move the electron from the one place to the another orbit, one orbit to another orbit, one place to another place. That can be the energy transfer from the atom to electron. It can be calculated. Energy is the force multiplied distance more. So the force is equal to E squared divided by 4 by E0 R squared. So this equation then we can calculate the energy absorbed by the electron from the atom. And then based on this principle, we have to calculate the problem. The problem is question 45 in the assignment. Suppose an atom A has an ionization energy. Electron volt and atom B has an electron attaining of 4 electron volt. So suppose atom A and B are 5 Armstrong apart. What is the energy required to transfer an electron from A to B? So this program, so in this case, electron A got the ionization energy 5 electron volt, and the atom B has the ionization energy 4 electron volts. So the A and B's are different between the A and B is 5 Armstrong. So what is the energy required to transfer the electron from A to B? So this means that this A and B's are the 2 electrons. They got the energy and they are distant. So that we need to transfer the energy from the A to B, need to be calculated. So firstly we have to calculate the force. The force between A to B need to be calculated. For equation given, the E squared divided by 4 by E0 into R squared. So this is that we can calculate the force between A and B. So this force equation is E squared divided by 4 by E0 R squared. So E is the force. So electron force. So electron force can be calculated this way. The electron force E is 1.6 multiplied 10 power minus 19. This is the electron charge. So this electron charge is the square divided by 4. Pi is 3.1416. E0 is this is for the constant. The E0 value is given the 8.854 multiplied 10 power minus 12, and then distance. So I mean the distance. Distance means the 5 Armstrong. The 5 Armstrong unit means 5 multiplied 10 power minus 10 square. So this is the 5 multiplied 10 power minus 10 square. So by solving this equation, what you can get is the force equal to F is equal to the 9.2 multiplied 10 power minus 10 Newton. So this is the force. This force is occurring between the atom A and the atom B. So this force. After that, this force is moving the electron. So to change the electron from the one place to another place, the distance traveled needs to be the 5 Armstrong. The 5 Armstrong multiplied force, we can calculate the energy. So this is the energy required to move the atom. So this is the energy, the W is equal to F multiplied H. So F is 9.2 multiplied 10 power minus 10, and the H will be the 5 multiplied 10 power minus 10. So by solving this one, the final answer will be 4.502 multiplied 10 power minus 19 joules. So this energy will be required to remove the one atom to another one place to the another place, from the A place to B place. So this energy need to be required. So this is the ways we can calculate. So this means that between two atoms, there are forces acting on. So that this force, due to this force, the atom will absorb the energy. So this energy can be calculated. The equation will be the Wi equal to minus R pi by R plus the beta by R squared. So they are combination of the attractive force and the repulsive force. The force between the two atoms can be calculated. The formula is E squared divided by 4 by E0 R squared. The energy is the force multiplied the distance more. So that from the atom A to atom B, so we can calculate the force. Therefore, with the force multiplying the distance, so that will be the energy. So this is the force and the energy between the two atoms. And the next one will be the the next one with the dielectric properties of the insulator in the static field. So we put the insulator in the static electric field. So the insulator can also be the dielectric properties can happen. So this equation can be calculated. Surface integral of the ds is equal to the summation of the charge U. This means that d is the density of the field. So this area, this is the electric charge here. So the electric charge we circulate. So we combine the all electric charge. So this becomes the field density. Field density is a D, and ds means that this circular. So this the whole area, all our charges are enclosing. So that you have to travel the whole area, the whole gap, and we combine the all the electric charge. So this means that all charges need to be combined. This is summation of charge. This is the total charge. So this becomes the surface integral of the cup integral of GDS is equal to summation of the Q. So this is for the electric charge and the field density relationship. So in this case, D is the electric field and the density. CS is charge. And summation of Q is equal to the sum of electric charge. So cup integral DDS is equal to summation Q. That will be there. We can calculate the sum of the electric charge by this equation. And also that we have to calculate the electric potential. Potential means that this is for the charge. So this around the charge will be there. We got the potential. This we got the potential. So this near the charge there will higher potential. Far from the charge there will be less potential. So this become the potential 1. Here with the potential 2. So potential 1 is usually greater than the potential 2 because of the point. This number 1 point is closer to the charge than the number 2 point. So the near the charge, higher potential. Therefore, when you are closer to the charge, the potential will be the field potential will be higher and higher. Therefore, we can calculate the field intensity. So the electric field intensity depends on the distance from the charge. Distance and the potential can be calculated. In this case, V1 and V2 distance will be V1 minus V2 can be calculated. Then will be the integration EDR. So this is the equation to calculate the potential. The electric potential between the point 1 and point 2 can be calculated by minus integration EDR. This formula, we can calculate the electric charge. So electric charge and the potential we can calculate. So therefore, for the typical value, the electric potential magnitude can be calculated. potential VI is equal to the Q divided by 4 by E0R. So this equation. So in this case, the Q is the electric charge. So the unit will be the Coulomb. And E0 is constant. 4 by multiplied 8.854 multiplied 10 power minus 12. R is the distance. And VR is a potential gradient. So electrical potential can be calculated. So this is depending on how far from the electric charge. So when you bring the particle to the closer to the electric charge, the potential will be bigger. So this electric charge can be calculated by equation VR is equal to Q divided by 4 by E0R. So this is the way when the electric field are influencing on the particle, how their charge can happen. So in the meantime, the electric charge can be stored by the capacitor. So capacitor function is that capacitor can store the electric charge. Capacitor got the two plates. This is the positive plate and this is the negative. So here between this one we use the insulation or the dielectric. So this is the capacitor. So capacitor can store the electrical energy. The capacitor can store the electric charge. And energy. And therefore the capacitance can also be calculated. So the voltage is equal to V equal to E divided by D. And then will be the electric intensity, electric field divided by the distance, you call the electric density. And capacitance can also be calculated divided by the Q divided by V. So C is the capacitance, Q is the charge, and V is the voltage. So this equation for the capacitor electric charge calculation. So the capacitance value C is equal to E0ER A divided by D. This means there are two areas. This area they are found in the capacitor. So this area is 1 and D is the distance. So A is the area of the plate. And D is the distance. And E0 is permittivity. Permeability. And EI is the relative permittivity. So this is the way that capacitor. So as to this say that we're talking about the electric field energy. When there's an electron moving around the nucleus, so the electron retain the energy. So this energy is caused by the attraction force and the repulsion force. So the electron suffer the force. The force can be calculated E squared divided by 4 by E0R squared. So that to move the electron from the one place to another place, you have to spend the energy. So this energy can be calculated if you equal to F multiply A. So this place because there are so many charges, so all the charges can be combined by this formula. So that this you accumulate the all charges, then will be the all charge density multiplied distance travel, then will you can combine the charge. So when you move the one place to another place, electron moving, so electric energy will be changing. So this place is closer to the charge, then will be the higher potential. Higher potential, so then with the potential difference can be calculated by the formula V1 minus V2 equal to minus integration EDR. So that function means the electric field can be happening, so the the electric field can be stored by the capacitor. The capacitor can store the electric field, so that the capacitor value can be calculated. The electric field charge divided by voltage, so that the capacitor value can also be calculated. E0 ER A divided by D. In this case, E0 is the permittivity, ER is the relative permittivity, A is the area of the plate, and the D is the distance. So this is the electron and the electron capacitance properties and electric field energy are also related to each other. Talking about the current density. Current means the rate of change of the electric charge. This is the current. So when electric charges are moving from the one place to another place, so this means that we are changing the electric charge volume. So the rate of change of the electric charge, this is the electrical current. So electrical current unit with the ampere, they with the coulomb per second. This is the ampere. So this electric current, electric charge. Now when the electric current is flowing, we also calculate the electric charge because of this electric charge are called the density. Because of the electrical current is similar to the electric charge, so the electric charge are accumulating in the surface area. So that we call the charge density. The charge density and electric current relationship. So we call the equation. The equation is equal to the I is equal to J multiplied A. This means the I is the electric current. So unit with the ampere. And J is the current density, charge density. So, or the current density. Unit with the ampere per meter square. And A is the area of the area. Meter square. So this equation we can calculate. Electric current is equal to charge density multiplied area. So this is the way we can calculate the electric current. So this means the electric current is also the accumulation of the electric charge. So that all the electric charge are accumulated in the surface area. We can also happen the current density. So current density equation is equal to I is equal to the J multiplied A. So in this case, J is the current density, A is the area, I is the electric current. Then also we also talk about the electrical conduction in the semiconductor. Electrical conduction in semiconductor. So as this says that we are talking about the general formula. Here we talk about the general formula of the atom. So when the atom retain the potential energy, to move the atom electron from the one place to another place, you have to spend the force. The force, so therefore, multiply with distance, you can calculate energy. So this is the generalized formula. Now we can also talking about the static field. When the static fields are the static field, you can calculate the electric density multiplied the distance is you can calculate the static field charge. So static field is usually related by the capacitor. So capacitor store the static electrical energy, static charge. So the capacitor value can be calculated by the flow formula. Charge by voltage is the capacitor value. The capacitor function is the ability to retain and store the electric energy. In the meantime, electrical current is flowing. In this case, the current density multiplied area is the electrical current. So as this say that we can talking about the static field. The next one will be the electrical conduction in a semiconductor. So electrical conduction in semiconductor means semiconductor can also conduct the electricity. So when the electric current flow into the semiconductor, what happens will be there? We can write down the equation. The equation will be the MVR is equal to E mH divided by pi. So this is the electric field. So this means the M is the mass of the electron, V is the velocity, I is distance, this is the N this is the orbit number, H is the constant, pi. So this is the equation to calculate the electrical energy. MVR equal to NH divided by pi. M is the mass of atom. V is the velocity. R is the distance. N is the orbit number. H is the Planck constant. So this is the equation to calculate the electrical energy flow, electrical current flow in the semiconductor. In the meantime, we also calculate when we receive the and so electricity is similar to the waveform. When the waveforms strike the surrounding electron, so it can produce electrical voltage. So this voltage can be calculated because of the when you atom suffer the certain kind of the energizing or initiations energy, so this electron will be moving. So this energy will be calculated by equation. So in this case, equation equal V equal to mu E. So mu is the permeability, and E is the voltage, and then there E is the constant, and then you can calculate the voltage. Equations are V is equal to mu multiply E. So mu is the constant, V is the voltage, and E is the electric field intensity. So this is for the two equations we utilize to calculate the electrical current conduction in the semiconductor. So the MVR equal to NH divided by pi. This means when the electric current is passing through the semiconductor, so especially the electrons are moving, so those electron mass multiply, velocity multiply, distance traveled is equal to the orbit number multiplied Planck constant divided by pi. And in the meantime, this electron also carry the voltage. This voltage can be calculated by equation V equal to mu E. And then we solve the problem. Okay, this problem is a given a Jamesium crystal specimen 1 millimeter has a total of the 2/5 multiplied 10 power 7 electron in its conduction bond. For electron current flow, where there is a field of the 6 volt per centimeter parallel to the 1 field of the Joule. So this means this Jamesium got that 2/5 multiplied 10 power 7 electron is ready for the conduction. So that when you put the 6 volt per centimeter electric field, so electrical current will be flowing. The electron will be flowing, so that we have to calculate the amount of the electron current. So this means that field is put on the electron. So this will be the we can calculate. So that will be for the Jamesium mu is equal to 3900 because mu equal to 3900 for Jamesium. So firstly we have to calculate the voltage. The voltage can be calculated. So voltage is we can calculate so mu multiply E. So mu is 3900 multiply E. E value is given, this will get 6 volt per centimeter to 6. So by solving this one, you got the 23400. So 23400 we got. And after that, electron current can be calculated. So electron current is a Jn multiply and E multiply V. So this equation. The Gn is the electron current. E is the electron charge. V is the volt. The volt is that we also calculate here. V equal to mu multiply E. So 23400. So therefore the Gn is the electron current can be calculated. How many electrons? Electron got the 2/5 multiplied 10 power 7. 2/5 multiplied 10 power 7. One electron got the charge. Electron charge will be the 1.601 multiplied 10 power minus 19. And V is at 23400. So So by solving this one, that will be the, by solving this one, 9.36 multiplied 10 power minus 8 ampere. Ampere per centimeter. So this is the electron current density. So ampere per centimeter. So this is the way we can calculate electron charge. So up to this stage that we are talking about the electric field. When the electron is circulating the orbit, the electron got the energy. So the electric energy means that the electron and the nucleus are their attraction and repulsion. So it can cause the potential energy. So this potential energy as well as the force. The force between the electron and nuclei is the E squared divided by 4 by E0 R squared. And energy is the force multiplied by distance. So to remove the electron from the one place to another place, you have to spend this energy. So in the meantime, electric charge are also accumulated in the surface. So the surface electric charge equal to the surface cup integral of the ds equal to the summation of the Q. So the electric charge, when you are closer to the charge, potential will be higher. The potential difference can be calculated V1 minus V2 equal to in minus integration EDR. So when we talk about the static field, when the static field is impressed on the electron, so that the static field we also mean that this capacitor will retain a charge. So the capacitor value will be Q divided by V. And that's why it says moving field. So the dynamic field, the electrical current is equal to the current density multiplied area. In the meantime, the electrical current can also pass in through the electron. For the electron, we have to utilize the equation MVR equal to NH by pi and V equal to the mu into E. So that this problem is the Japanese crystal. They got the 2 by 5 multiplied 10 power 7 electron in the conduction bond. So that when you put this at 6 per centimeter, you have to find out the current density. For the Japanese, U is 3900, V equal to mu multiply E. So then we calculate the V value. And then you substitute this formula G is equal to NEV, then you can calculate the electron current density. So this is the ways that we're talking about the electron energy, potential energy, and electric charge, and the static field, and moving charge, and also the current flow in the semiconductor. Why is the electron and the hole in the semiconductor? So when this is for the electron is, this is all the atoms are combined with the electron. When the electron is coming out, it can cause a hole. So negative coming out, so this hole is a positive. Whenever the electron coming out from the place, the hole will be there. So the electron got the negative charge. Normally the electron and hole are combined so that there will be zero charge. Once the electron is coming out, so only hole left. So hole got the positive electricity. So that in this case, we have to put some more energy level. Up to certain energy level, electron cannot move. But at the more than this starting in the threshold level, so this additional force is forcing out the electron from moving from the one place to another place. So this threshold level we call the Fermi level. Fermi level is, this is the critical level. Until which the electron can remain at their original place. When the external energy is more than this critical level, the extra energy moves the electron out from the new atom. So this is the way we can calculate. So that the electron now once they move from the atom, this electron will have the kinetic energy. So this kinetic energy of the electron can be calculated half mv square is equal to E minus Es. So this is the equation we can calculate. So E is the Fermi level. So E minus Es means the difference between the energy level, Fermi level, and the half mv square electron will attain the kinetic energy. So this Fermi level can also be calculated by equation. So this is the Fe is equal to Fermi level. Fe equal to 1 divided by 1 minus E power A the power E minus Es divided by the 273. So this is the way we can calculate for the Fermi level. And then we solve the problem. So this problem is given In this case, when the electron suffer the excess energy, it will move out so that the kinetic energy can be calculated E minus EF. So that this EF is a Fermi level. Fermi level is 1 divided by 1 plus E power E minus EF by 273. So this problem is determine the average energy of the electron in the conduction band of the metal at the 0 degree Kelvin as a function of the Fermi level. So that we write down the equation. This is the Fermi level Fe equal to 1 divided by 1 plus E power E minus EF divided by 273. So this equation. So this is the equation that we can calculate. So in this case, at the T is 0 at the 0 degree, so that we can write down the equation. That will be the 1 plus E power E minus EF by 273 is equal to the 2. So this is for the specific equation. So by this way, you solve this equation. So by solving this one, so the E minus EF is equal to so this is for the equations we can calculate. This for the at the 0 degree centigrade. So this is Fermi level is equal to the 1 plus E power E minus EF divided by the 273. So this equation. So at 0 degree Kelvin, E is around the 2 by 3 EF. So this is the answer. And so we write down the equation, determine the average energy of electron in conduction band at the 0 degree Kelvin. So in this case, we write down the Fermi level, Fe is equal to 1 divided by 1 plus E power E minus EF divided by 273. At the 0 degree Kelvin, due to this practical experiment, E is approximately 2 times EF. The next problem is a metal. A metal has its Fermi level 8.95 electron volt above the bottom of the conduction band. Write the equation for momentum of the electron. The equation for the momentum can be calculated. The general equation is half mv square is equal to E minus EF. So in this case, energy state per volume. The equation energy state per volume can be calculated. So that will be 2 power 9 by 2 and power 3 by 2 by E minus EF power 3 by 2 and divided by 3h squared. So this is the equation. So in this case, we can substitute the electron mass 2 power 9 by 2 multiplied with m is equal to the 9.1 power multiplied 10 power minus 21 power 3 by 2 by 3.14. E minus EF is a Fermi level 8.95 electron volt. So we substitute 8.95 power 3 by 2 divided by 3h. So 3h value is a 6.624 multiplied 10 power minus 34. So that will be the 3h power 3. So by solving this one, we can calculate the energy level by volume of the electron. Okay, so I summarized tonight's lesson. So firstly, we are talking about the potential energy and the energy in the electron. Talking about this energy, when the electron is moving the nucleus, it can cause a force between the electron and nucleus, so the electron possesses the potential energy. So we discuss the electron for the static field. For the static field, electrons are stored by the capacitor. So capacitor can store the charge. So we talking about the capacitor value, and for the moving electric field, field intensity. So current density density multiplied area, we can calculate the electrical current value. So this is the moving charge and the static charge. And also that we explain about the electron flow into the semiconductor. When the electron flow to the semiconductor, we can talk about the field level, energy level, their calculation I saw. And finally, we're talking about the Fermi level. So at one starting stage, the electron can remain at the original place. That when the energy level is more than the level, the more than the starting state, or threshold level, so electron can be more out. So electron will possess the kinetic energy. So this is the kinetic energy of the electron, and the potentials are different, Fermi levels are energy different. That equation, that Fermi level equation can be calculated 1 divided by 1 plus e power e minus ef divided by 273. And then this another program is that we put the electron energy state by volume can be calculated by the equation 2 power 9 by 2 n power 3 by 2 pi multiply e minus ef power 3 by 2 divided by 3 h power 3. So that means that we put this down the energy to the electron, so the electron possess the energy by volume, that's this equation. So tonight the thing is how much energy stored by the electron to move and to flow into the semiconductor. Last week we talked about the energy transfer.